Well, how's everybody doing out there? Well, hopefully everybody did a good job reviewing sections 8.1, 8.2, and 8.3, all the background information that we're going to need in order to do our hypothesis testing, and is prepared and ready to do our first hypothesis test. So at the very beginning here, I've got how everything's going to be broken down in terms of our different steps. So if you remember, we talked about step 1 in the previous sections about how to set up our null and alternate hypothesis. So remember, we want to make sure we have our contradictory statements. So if we've got a greater than, then the other one has to be less than or equal to. If we have a less than, we have to have greater than or equal to. And again, big reminder, we want to make sure that our H1, where our claim lives, never has the equals. So the equals always goes with our null hypothesis. All right. So the second thing that we're going to do is we want to calculate the test statistic, which in this case is going to be our z-score. And so we'll talk about how to do that when we get to our example. And then we want to calculate our p-value. And so what we're looking at is this is broken into one of three different possibilities depending on which claim we're actually using. So in claim, the first bullet, we've got H1 is the mu not equal to the value. So when that occurs, this is what's called a two-tailed test. So, because what happens is we've got those two shaded regions, and so if we end up in either of those shaded regions, that's actually the good area that we can live in. And if we end up in the unshaded region, this is going to be our bad area. So for our two-tailed test, we end up having the two upper and lower shadeds, and we're only going to have two-tailed tests when it comes to the equals, not equals situation. And so what we're doing is we're calculating the area of this and this. So notice that's why we end up doing the 2 times the normal CDF. And then the z-score is going to be our z-score from above. And so sometimes I like to call this z sub t, since this is going to be our test statistic. And then later on we're going to talk about a zc, which I call the comparison z-score. So I use two different z-scores when I'm doing these. And so I'll talk about both of them when we get there. All right. So for our second case is if mu is greater than the value. So since it's greater than, notice that we've shaded the upper part. And so this is going to be our good area. And then this would be our bad area if we happen to fall into that region. And then finally, our last situation is if mu is less than the value. So now we're shading the lower end. And so again, this is going to be our good area, and this would be our bad area for these types of problems. And then finally, our last step is to draw our conclusion based on this p-value that we've actually calculated. And so if p is less than alpha, we're going to reject h naught, and if p is greater than alpha, we're going to fail to reject h naught. So these are going to be the same 4 steps that we're going to actually use for all of our hypothesis testing from this point on. So let's go ahead and just dive in and look at an example to see how these actually work. All right. So for example 1, we've got a social scientist suspects that the mean number of years of education for adults in a certain large city is greater than 12 years. She surveys 100 adults and finds that the sample mean number of years is 12.98. Assume that the population standard deviation is 3 years. Test the claim. All right, so we've got a lot of numbers going on here, so we do want to make sure we identify all the different parts and what they mean. So the 12 that we're talking about, so this certain large city is greater than 12. So this is going to be related to our claim. So that's actually the claim that we're trying to solve in this case. So that's going to be related to our alternate hypothesis when we get there. So this 12 is referring to the population mean, and it's going to go into step 1. So our N, of course, is going to be the 100, the number of people surveyed. Our sample mean is the 12.98. So that's our X bar. And then our population standard deviation is 3. And so if you remember in this section, everything that we're dealing with is the same as 7.1. The population standard deviation is given to us. All right, so the only thing that's actually missing from this problem is they don't talk about a confidence interval or an alpha level or anything like that. And so the rule of thumb is if no confidence level is given, then what that means is we want to use a 95% confidence interval to test our claim for this kind of stuff. So our alpha in this case would be 0.05 is what we're looking at. So our alpha, oops, sorry. So our alpha is 0.05. All right, so let's first start off with our step 1. Let's figure out what our claim is. So we've got our claim is that the certain large city is greater than 12. So that means our H1 is going to be mu is greater than 12. Our H naught is going to be mu is less than or equal to 12. So that's our first step. So that's the first thing that we want to do. So now what we want to do is calculate this test statistic. So this is going to be the z-score of our sample, which gives us an idea of how unusual our sample is, assuming that the true population mean is 12 ounces or less, our null hypothesis. So our z-score, so this is going to be our z sub t, our test statistic. And so we calculate this just like we would a normal z-score. So we're going to take our sample mean minus our population mean, all divided by our standard deviation, divided by square root of 100. And so when we plug that in, we're going to get, so 12.98 minus 12 divided by 3 divided by square root of 100. And so we've got a z-score of 3.27 in this case. So 3.27. So our z-test statistic is going to be 3.27. So now what we need to do is we need to calculate our z comparison score in this case. So we're trying to figure out what z-value goes here and separates that lower or upper 5% from the lower 95% in this case. So the way we calculate our z sub c is we're going to use our inverse norm. And so the good thing is, since this is symmetric, I'm just going to go ahead and calculate the lower 5% and then just use the positive version of this. So when I type it in, I'm going to type in 0.05, comma 0, comma 1 into my calculator, and it's going to give me the negative version, but I'll just change it into a positive since I know I want to be on the positive side. So let's go ahead and type this in. So second vars, inverse norm, 0.05, comma 0, comma 1. So it looks like we get negative 1.64, but again, we're going to use the positive version. So our answer is going to be, 1.64. All right. And so again, what we want to do, the way I do these hypothesis tests is I do kind of a two-test system. So I use the p-values, but then I'm also going to use this graph as a way to talk about whether we should think we're going to reject or fail to reject before we even get to calculating the p-value. So for this one, since I know the blue area is going to be reject H naught, because that's going to be where our claim lives. If we land in the blue area, that's the good area. So if our z-score, our test statistic, is above 1.64, we're going to reject H naught. If our test statistic is smaller than 1.64, then we're going to fail to reject H naught. So if we go back to our 3.27, does our 3.27 live in the white area or the blue area? And so hopefully everybody at home is yelling, oh, it's over here in the blue area, because it should be probably even further to the right than that, but it should be somewhere over in this blue area. So according to our test statistic, it looks like we're going to reject H naught in this case. All right, so now let's verify that's true by calculating our p-value and seeing if it's less than our alpha of 0.05. All right, so now to calculate our p-value, what we're going to do is use our normal CDF. And so with this one, since it's greater than, the z sub t is going to be our lower bound. And then we're going to put some ridiculously big number in here. And then our 0, 1. And we want to see if that probability is less than 0.05. So if we plug this in, our z of t is 3.27, comma, this ridiculously small number. So let's throw this in the calculator real quick. So normal CDF, 3.27, comma, 0, 1. And so lo and behold, we've got 5.37 e to the negative 4. So if you forget what that means, so let me write it down here. Oops. There we go. So we've got 5.37. So e to the negative 4 is the same thing as saying times 10 to the negative 4, which is scientific notation. And so what this means is we want to take and move this decimal 4 places to the left. So if we start here, we're going to go 1, 2, 3, 4, 3, 7. So our number is 0.000537, which is definitely way less than 0.05. So it looks like we are going to reject H naught in this case. So our step 2 and our step 3 both go together. They both support each other, so it definitely looks like we've done everything correctly. So finally, our last step is to write a little sentence talking about what actually happened in this case. So in this case, we reject H naught. There is sufficient evidence to support the claim that people have more than 12 years of education. And that's it. So that's going to be pretty much how we do all these different hypothesis tests. There's a lot of steps, so don't get me wrong, there's definitely some trickiness to it. The nice thing is, like, we know everything, we've done everything up to this point at some point in time, so now it's just a matter of putting it all together and going from there. So I'm going to stop the video right now, so that way if you need to rewind, look at it again or anything, and then I'll do the next example on a separate video. So good luck, and let me know if you have any questions.